Hello, physics class. Today I'd like to give you a few helpful hints and tricks when we are trying to solve two-dimensional motion problems. I call these the special cases of two-dimensional motion, and they work most of the time, some of them all the time, but they will be helpful as we start to solve problems. The first one is the unique case of the vertex or the top point of the path that the projectile is taking. When you release the projectile, or throw the projectile, or kick the projectile, or whatever you might be doing to this projectile, that projectile has some vertical velocity and some horizontal velocity, Vx and Vy. So there's your Vx, and here's your Vy. And as time goes on, that Vy will change. It's going to get less and less and less because gravity is pulling on it, and that force is causing a downward acceleration, which is slowing down your Vy. When it gets to the peak, it has stopped going up, and it is getting ready to come down. So at that point in time, special case number 1, Vy equals 0. So when your projectile is at the peak, Vy is always 0. I'll put this here so you can copy that down in word form. You can pause the video to make that happen. The second special case is not at the peak. The second special case, this one is one that is not always true, but I drew it in a scenario where it would be true. This is when your elevation that the projectile is released from, so the elevation is the height, or the delta y. So we threw this ball and it had some elevation, some delta y. So it was some distance off the ground. If this is a human, if you're a human like me, not too tall, that might be 1 meter. So my delta y is 1 meter. Then it goes up, 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 up. Then it starts to come back down, 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 down. When it gets back to 1 meter, so if I throw this ball to my friend, and my friend is the same size as me, and they catch the ball, comes back down at 1 meter, this is another special case. When the elevation of that the ball is ending at is the same as when the ball is released, your Vy, so my Vy is going to be negative because now it is going down. And my Vy, let's say I threw it up at 5 meters per second. It goes up, slows down, stops going up, starts coming back down, 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 and it is negative 5 meters per second because the same amount of time that it took gravity to slow that thing down going up, it had that same amount of time to make it speed up coming back down. So 5 meters per second when it was originally left, now it is negative 5 meters per second. So special case number 2, I'll write this out again for you so you can read. When the projectile reaches the same elevation it was fired from, the Vy is negative the Vyi, the initial vertical velocity. So when it reaches the same elevation, my Vyi, 5 meters per second, will be negative 5 meters per second. So Vy is negative, Vyi was positive at that same elevation. If this ball continued and it went to the ground, it fell an extra meter, then this case would not be true. So this has to be when they reach the same elevation. So this will be helpful sometimes, not all the time, but sometimes this one will be helpful. The third special case deals with time. And so it takes time for projectiles to move. It takes time for them to go up and come back down. And this one might be kind of obvious, but it also will be helpful sometimes. I throw this ball to my friend, And by the time that ball gets to my friend and they catch it, that took 2 seconds. So, 2 seconds, it left my hand, went up, came back down, they caught it. At the halfway point, when it's at its vertex, guess what my time will be? My time will be 1 second. Or whatever my total time was, it will be half of that. So time in the middle, t here, is half t total. So time in the middle is half of the total time. And that is also only true when it reaches, when it's caught, or it ends at the same elevation that it was released from. So the time it takes to reach the vertex is half the time it takes to reach the same elevation on the way down. So sometimes this will be helpful, sometimes this won't be helpful. But this is the third special case, and I hope you'll have some time to use these, and it'll help make sense of your problems.